Welcome to Introductory Chemistry with Dr. H. This is a video about significant figures. Particularly, we're going to talk about what significant figures are and why we need to care about them. And then we're going to talk about determining the number of significant figures in a number that we're given. Okay? So what are significant digits or significant figures? Significant figures indicate to the reader of a number or a measurement how certain we are about that measurement. So let's, for example, look at this measurement of this block of wood using a tape measure. So if we zoom in on the end of the block where we're going to make the measurement, someone could see that this block of wood is at least 17.5 centimeters, 17.6, 17.7, and maybe it's 17.8. It's very difficult to tell whether it's 17.8 or slightly less. So someone making this measurement might write down the measurement as 17.80. That's possible. They could also write down the number 17.79. That also seems like a reasonable number. Two people looking at the same measurement would write both of those numbers, and they're both sort of equally accurate given the instrument that we're making the measurement with. What that indicates is this last digit is our guess digit in that measurement. So that last digit is the last significant digit. It's the last digit we can report with any confidence. And so if we reported any other numbers, if we said 17.081, that one would be completely meaningless. We don't know anything about the thousandth place. We only know something about the hundredth place in this measurement using this particular instrument. So in this case, we would say that both of those measurements, both of those numbers, have four significant figures. The last number, the most precise number in that number, in the top number is the 0, and the bottom number is the 9. That's the number we're uncertain about, and we can't say anything about the next significant digit, the one in the thousandth place. So both of these numbers would have four significant figures, and that indicates to the reader that we're uncertain about anything beyond the hundredth place in that measurement. We need to care about them because we also are the consumers of information of measurements or reported measurements, and we need to know when we look at a number how precise that measurement is. So we both need to know how to communicate our level of precision when making a measurement. We also know how to read and understand how accurate or precise a measurement is when it comes to us. So let's say take those same two measurements, this 17.80 and 17.79. Let's say we were given those measurements and we were asked how many significant figures are in each of those measurements. We have a set of rules to help us make that determination. The first one is all non-zero digits in a number are significant, and all zeros that are trapped between two different non-zero digits are also significant. So if we look, say at this bottom example, this 1 is significant because it's non-zero, the 7 is significant because it's non-zero, this 7 is significant because it's non-zero, and that 9 is significant because it's non-zero. 4 of the digits in that number are significant. So as we already said, and as makes sense based on the tool that we use to make this measurement, this number has 4 significant figures, right? 4 sig figs for that number. The 17.80 has a trailing 0, so we need more information. There's a 0 on the right. It's hard to tell right off whether that number is significant. So let's keep reading the rules. Zeros to the left of the first non-zero digit are not significant. Neither of these numbers have a 0, but if we added a 0 here or added a 0 there, that 0 would not be significant, and it wouldn't add to the significant digits in that number. Okay, so we're clear on that. Let's see. If the number is greater than 1, all zeros to the right of the decimal point are significant. So here's the rule that helps us on the 17.80 measurement. So we can see in this number, the 1 is significant because it's a non-zero number, the 7 is significant because it's a non-zero number, the 8 is significant because it's a non-zero digit, and that 0 is significant because it follows to the right of a decimal point non-zero digits. So if a number is greater than 1, all of the zeros that are to the right of the decimal point are significant. So as we already know, all 4 of the digits in that number are significant, and by writing the number 17.80, we would have communicated that to the reader of that number, and they would also understand that. Okay, so let's do another example to deal with this last rule. Let's say we were making a different measurement, and the measurement was reported as 2,000 centimeters. When we're looking at that number, it's impossible for us to know without more information how many significant digits that number has. So this is a number without a decimal point. The decimal point hasn't been provided. All trailing zeros, the zeros to the right of any non-zero digit, may or may not be significant. If it's trapped between two non-zero digits, we know it's significant. But if it's following to the right of a digit that's not 0, it's hard to tell. The person reporting that number would have to indicate which of those digits is significant. If this number was just a really rough estimation, 2,000 centimeters, right, roughly 2 meters, someone was eyeballing it, that's as close as they can get. there are two different ways we could indicate that that's the level of precision of that measurement. One way is we could put a bar over that guess digit. It's 2 meters plus or minus. It's a really rough estimate. So putting the bar over that number indicates the last significant digit, that guess digit. We could also indicate that same number using scientific notation. So if we said 2 and put a decimal point there, times 10 to the third, we could look at that number and say 2 point, so there's no zeros trailing that digit that's greater than 1, so that's one significant digit. Both of those numbers have one significant digit. And so those would be two equivalent ways of representing that. Let's say we were using a slightly more precise instrument to make that measurement. So this time, let's say we were certain to the hundreds of centimeters. So we were certain about the 2 and the 0, the first 0, the hundredths place, but we're not certain about the tenths place or the units place. We could indicate that level of precision with a bar over that second 0 or that first 0, that second significant digit, or we could equally well write 2.0 times 10 to the third centimeters. That 2.0 has two significant figures, right, by rule number 3. If a number is greater than 1, all the zeros to the right of the decimal are significant. Both of those are significant. Both of these numbers have two significant figures, and that would indicate the level of precision. So we could keep going with this, right? If we had a slightly more sensitive instrument, right, we could put a bar over there, so we're certain to the tens place. We're plus or minus 10 centimeters on that measurement. So here we could add one additional 0. 2.00 times 10 to the 3 centimeters would be an equivalent way of representing that number and the number of significant digits. Both of those numbers then have 3 significant figures. And we could keep going with that, right? We could keep going with this process. If we moved out one additional place, we could put a bar over that units place. So we know it's 2,000 centimeters plus or minus 1 centimeter, right? So now, if we wanted to use scientific notation, which is a good way of doing that, we could say 2.000 times 10 to the third centimeters. Those are equivalent ways of representing the fact that we have 4 significant digits in that number. So I hope you now understand what significant digits are, and if you're given a number that you feel confident that you could determine the number of significant figures in that number and thus the precision of that measurement. Hope you found this video helpful.